83. Did it say hard next to it?
Yeah.
Oh. Okay. Well, find a cubic equation. Just write f of x equals ax cubed plus bx squared plus cx plus d has a local maximum value of, I'm sorry, f of x?
Yeah. Ax squared.
No, it's cubed.
X cubed.
Plus bx squared plus cx plus d. Local maximum value of 3 at x equals minus 2. And local minimum value of 0 at x equals, did I go too fast?
No, do you want to advocate for you?
Max at -2 comma 3, min at 1 comma 0. Okay. So this is a problem that is going to turn into something that you might have had and you might have run into it. Hopefully you ran into it in algebra. Maybe if your algebra is a little weak, you're going to have trouble when we get there. But, so that was it, wasn't it? That's the only information.
Yeah.
Well, all right, let's just go for it. Maximums and minimums, they're going to occur when the derivative is 0. So the derivative is 3ax squared plus 2bx plus c. So we have a little information here. We know derivative at -2 will equal 0, and the derivative of 1 equals 0. So what does that tell us? Well, if I plug in 1, I get 3a plus 2b plus c equals 0. And if I plug in -2, what am I going to get? 12a minus 4b plus c equals 0. Right? 3 equations and 3 unknowns. Algebra 2, hard algebra 2. Usually just do 2 equations and 2 unknowns. Let's subtract this equation from this equation. 12 minus 3 is 9a minus 4 minus 2 minus 6b equals 0. So now we have at least one equation and 2 unknowns. We do know something else. I don't want to pull it in quite yet. There's no, that's it. The problem doesn't say anything else, does it? Oh, I'm sorry. Of course it does. These are points, right? Right? So f of 1 is 0. So a plus b plus c plus d equals 0. And f of 2 is equal to 3. So -8a plus 4b minus 2c plus d equals 0. Okay, what can I do with that? Well, again, I can pull this trick. Let me subtract this from this. That's going to be 9a. Maybe I should. Minus this. That'll get rid of the d. That'll give me another equation of 3 unknowns. Should be careful putting a 9 next to an a. 9 9a minus 3b. C minus 2c is plus 3c equals 0. Oh, so I can already, you can already look at the big picture. Here's 2 equations and 3 unknowns. Here's a third. That's enough to find a, b, and c. So now I need to find a way to combine this with one of these, end up with an equation and 2 unknowns. So how am I going to do that? Well, and I want to get rid of c, right? So I get rid of c, I'll have another equation in a and b. This is hard work. It's simple, hard work. So I guess what I want to do is multiply one of these by 3 and combine it with this. So let's multiply this one by 3. 9a plus 6b plus 3c equals 0. Let me write this one down here. 9a, oh, they're going to make it easy for us, aren't they? Plus 3c equals 0. Now, I have to say, this is the kind of problem where if you don't do it carefully, you're going to make a simple mistake. Since it's early in the morning and I'm up here at the board trying to teach, trying to, chew down the law, you should keep an eye on me. If you see something wrong, let me know. Looks like if I subtract this from here, I get 9b equals 0, which means b equals 0. That can't be right, because that would mean a is 0, and I know the answer is different. Anyone look up the answer? A and b are not 0, are they?
Why would it be 9b? Because it's 6b minus 3b.
6 minus a minus is 9. Yeah, so, okay. Well, now I know now that I've tried the problem the first time, failed, I'm going to go back and I'm going to do it more, how shall I say, carefully. So, I'll write all this stuff down. F prime of minus 2 equals 0. F prime of 1 equals 0. F of minus 2 equals 3. F of 1 equals 0. And this is my derivative. Let's double check that. 3x squared plus 2b plus c. Okay, so let's write these down. So f prime of negative 2, that's 12a plus minus 4b plus c equals 0. That's my first piece of knowledge. You know, 4 pieces of knowledge. 3a plus 2b plus c equals 0. Carlos, could you do me a favor? Just check that I have max at negative 2, 3, and min at 1, 0.
The answer gives me an equation. Or you mean like...
Oh, wait a minute, hold on.
You mean like the question?
Yeah, on the question, just check that I've got those numbers right, because if I don't, it's never going to come out right. F1, that's a plus b plus c plus d equals 0. Oh yeah, I do need these 4 equations. And f of minus 2, that's negative 8a plus 4b plus minus 2c plus d equals, oh, equals 3. Oh, yeah, I'm sure I made a mistake here. Okay, so I want to combine these two to get rid of d. Then I'll have 3 equations with just a, b, and c, and then I'll have to work those. It's good to have a lot of extra paper around when you're doing this. Okay, let's try this. Let me give these letters A, B, C, and D. So I'm gonna do C minus D. So that's 9A minus 3B plus 3C equals minus 3. And since there's a factor of negative 3 here, I'm going to divide that out. Minus 3A plus B minus C equals 1. So let me write that down here. These combine to negative 3A plus B minus C equals 1. I guess I can move these up. Okay, so now I have these 3 equations to work on. And again, okay, now this looks a little better here. I'm going to add these two. Call this E. So C plus E. No, not C plus E. B plus E. So B plus E. So the A's go away, the C's go away. I have 3B and 1. B equals 1/3. Ah, so now I actually have B, which really helps. Okay, so if I plug B, well, I could plug B in here, and I'll just have 2 equations and 2 unknowns. I think that's what I'll do. Call this A prime, 12A minus minus 4/3 plus C, this B prime, 3A plus 2/3 plus C. These are equal to 0, or actually 4/3 and 2/3 by putting that here. Okay. So now I want to combine A prime and B prime somehow. How do I want to do that? Oh, I just want to subtract B prime. So that's 12 minus 3 is 9. And 4/3 minus 2/3 is 2/3. So that would make A equals 2/27. Does anyone have the solution here? Because if I'm wrong, I want to go back and find my error before I spend after class embarrassing myself. Yes. Do you have the answer? All I want you to do is tell me is B 1/3
It's giving me like, or I guess 1/9, and then it gives me like 2x cubed plus 3x squared. There we go.
Oh, well, E is 1/3. And A is something else. A is 2/9. So I'm off a factor of 3 here. Mark watching. Okay. All right. These are long and tedious, and you have to work at them. You can always check your work by going back and plugging into the original equation and finding out you made a mistake. Let me work on this. Okay. So, derivative is 3 squared plus 2b plus c. -2 is 12 minus 4 plus c. 1 is a, 3a plus 2b plus c, okay. And where did I? Try this again. This minus this is I told you it was a hard problem. I mean, what's hard is it's just so easy to make a mistake. I had a little extra time to fill in this class anyway, so we'll fill it in here. So these are 0 because it's, max and min. These are because we're given these points. Let me try again. This doesn't like the. Yeah. One is a plus b plus c plus d equals 0. And -2 is minus 8a plus 4b minus 2c plus d equals 0. And I'm going to subtract c from d. That's 9a minus 3b plus 3c equals 0. There's an alternate way of solving this, not on the board. Anybody here? Yes?
Equation C is equal to 3.
Thank you. There's an engineering student in this class. There's a different strategy here. You put everything in a matrix. 12 minus 4, 1, 0. This is A, B, C, D. 3, 2, 1, 0. now we have 9 minus 3, 3, 3. And this is equivalent. What we want is something that looks like this: 1, 1, 1, and then some, values here. I guess we'll try that. So let's multiply this by 4 and subtract it from here. So, oh no, that's not what we want. No, we might want it. Well, first thing, I'm going to divide this by 3. 3 minus 1, 1, 1. Okay. Now, I guess I'm going to multiply this by minus 1 and add it to this. So 12 minus 4, 1, 0. So minus 1, and I get 0. Minus 1, okay, that's 3. Minus 1, I get 0, 0. And I still have 3 minus 1, 1, 1. Okay. Now, I'm going to do this. All right. Yeah, I think I divide by 12. Minus 4/12, which is 1/3. 1/12, 0. What is this? Oh. I already know what B is here. Guess that happened. B is 0. Wait a minute. Is B 0? All right, so I've already made a mistake.
Quick question, how are you getting 9A minus 3B plus 3?
I plug 1 into this equation. Wait a minute.
I think that's...
Oh, that's C minus D. Okay, so D I get by plugging 1 in. C I get by plugging 2 in. And then I subtract C from D. So 1 minus minus 8 is 9. 1 minus 4 is minus 3. 1 minus minus 2 is 3. And D minus D is 0. And as Emily already pointed out, this is 3. Wait, yeah, 3. So minus 3. So that could be 3A minus B plus C equals minus 1. So let me go back. 12 minus 4, 1, 0. 3, 2, 1, 0. 3 minus 1 plus 1. Okay, that was a mistake, probably. All right, probably this method is just like the other. There's so many ways you can do it. Why don't I divide this by third? This is by 3. 1, 2/3, 1/3, and that's still 0. I'm going to switch these, which I can do. Be methodical about this. Multiply by minus 12 and add it to this. Multiply it by minus 3 and add it to that. So 2/3, 1/3. So I'm going to get 0. Minus 12 is minus 24 is minus 8 plus 4. Minus 8 plus minus 4 is minus 12. And then I'm going to multiply this by minus 12. Get minus 4 plus 1 is minus 3. Oh, come on, where did I lose this? This is not all zeros. Okay. But this is 0. And this times minus 1 plus the bottom is minus 2/3 plus minus 1 minus 5/3. Oh, wait a minute. Multiplying this by minus 3 and adding it. So minus 3, that's minus 2 plus minus 1 is minus 3. This times minus 3 is minus 1 is 0. This is minus 1. So I can multiply, I can divide by minus 3. Okay. So my question is B 1/3? Yes. It is 1/3?
Okay, good question. How are you figuring out which numbers you're supposed to be adding to the numbers that you have? And I completely forgot how to multiply matrices, so how
I'm not multiplying a matrix.
okay.
All I'm doing what's called row reduction, which is equivalent to what we did in high school where we eliminate and, combine. It just, have to list all the letters. These are the coefficients, the A, B, C, and whatever the equals. And so I can multiply one of these by any number. I can switch them. I can multiply them by a number and add it to another. So those are the row reduction things you can do, which are equivalent to, the elimination process. So, okay, so I want to multiply this by 12 and add it here. That'll get rid of, that'll put a 0 here. So if I multiply this by 12, I'm going to get 0, 0, minus 3, times 12 is 4. I'm going to get 4. Now I have 0, 1, 0, 1 third. And I want to switch these two. I'm going to divide this by -3. And now I'm almost there. I want to multiply this by -2/3 and add it to this. This is actually nice if you're doing, you want to solve these with a computer, you can put them in a matrix and you can kind of do this algorithmically. Let's do this one first. -2/3 times this added to this. So 1, 0, 1/3, -2/3 is -2/9. 0, 1, 0, 1/3. I'm just repeating these. 0, 0, 1, -4/3. And now I want to multiply this by -1/3 and add it here. So that's going to be 1, 0, 0 times -1/3 is 4/9. -2/9 plus 4/9. Let me try to get this time. -1/3. So this is positive 4/9. Yeah, that's right. So it's 2/9. And 0, 1, 0, 1/3. 0, 0, 1, -4/3. So that means that our function should be 2/9 x cubed plus 1/3 x squared minus 4/3 x plus d, we don't know yet. Well, if we plug in 1, we get 2/9 plus 1/3 minus 4/3 plus d equals 0. So 2/9 plus 3 minus 12. 5 minus 12 is 7, -7/9 plus d equals 0. So this should be 7/9. That doesn't sound right. It is. Oh. I don't know if I got it right this time. Let's factor out 4/9. Oh, that didn't work. Did it? Let's figure out 1/9. So we have 2x squared plus 3x squared cubed minus 4x plus 7. Starting to look like the answer. All right, so now we want to, no boardroom. erase the board. Let's at least see if some of this makes sense. If I plug in 1, 2 plus 3. Oh, that's not going to. Is it negative 7/9? Hold on. 2 plus, I think it should be 5. No. Now, what did I do wrong here? Oh, this is 12. 12, all right, let's try that again. 2 plus 3 plus 7 is 12, okay. So, I got this part right, 1, 0. Let's try negative 2. So, negative 8 times 2 is negative 16 plus 12 plus 24 plus 7. Let's try that again. 8 times 2, negative 2, 12, 2. Okay, so what do these add up to? 36, 20, 27. Just 27 divided by 9 is 3. Things you have to go through. Okay. I think we got it. So this is, what did we decide? It's 1/9 times 2x cubed, this is f of x, plus 3x squared minus 12x plus 7. So the derivative is 1/9 times 6x squared plus 6x minus 12. The constant goes away. And at 1, this is 6 plus 6 minus 12 is 0. So it has a min or a max there. Negative 2, so 24 minus 12 is 0. So it has a maximum there too. So we have fulfilled all the requirements. The only thing we haven't really checked is whether this is actually a max and this is a min. Might as well spend all this time here. What's the second derivative? It's 1/9 times 12x plus 6. I plug in 1, this is the second derivative. If I plug in 1, I get a positive number. That means the derivative is increasing, that means it's a minimum. And I plug in minus 2, I get a negative number, which means this is a maximum. All right. Now, I will grant you, it was a lot of work, and I had to sweat and embarrass myself here. This is, after we get past the integration and plugging in, it's a hard algebra 2 question. It's not a, maybe you needed pre-calc to do 3 equations and 3. This is 4 equations and 4 unknowns. I would suggest that you Google, 3 equations, 3 unknowns, or 4. And I think you will find a page where there's you can plug in numbers into your matrix and it will solve it for you. It's kind of like, you don't have to multiply by hand anymore, right? So you might as well use technology. If you're a computer student, CS student learning a language, you might want to think about writing your own program to do this. It would be a healthy exercise. If you do that, the one thing you want to look for is well, that's two equations and two unknowns, but you won't solve it because it's the same line. These are what we call they're not linearly independent. If you take linear algebra, you'll learn all about that terminology. So how do you identify this? And one way, if you're doing it with a computer, is you'll get to some point where, like one of your lines will be all zeros. That's one way. The other is if you look at this square matrix here, if you find its determinant, if its determinant is 0, this is what we call a singular or non-singular. It's a singular matrix, and then you can't solve it either. So same equivalent issues. It's almost too bad this is a calculus class and not linear algebra. This is what we would be doing in linear algebra. All right, any questions about this? If you felt that this was like too hard, notice on my, when I put up problems, if I put hard next to it, give it a try, but don't produce tears over it. Or get together with your other classmates and work together as a group. All right.
They're gonna go. I ran if they're gonna. I asked them. I was inside doing something to eat. I came out and I was here for me. I was looking for me. I said, I can go inside.
Okay, let me add some new recruits here. Andy is not here, is he? Okay. On Thursday, we were looking at L'Hopital's, we're finding limits. That's again, that's 4.4. Quick review with a limit. We have some limit. Limit is f gets close to c is 0, and the limit as x approaches c, g is equal to 0, and this limit is equal to the limit as x approaches c of f prime of x over 2 prime of x. Now, this condition is that the limit go to an indeterminate form. We saw a number of them. This is an indeterminate form. Infinity over infinity, negative infinity over infinity. We're going to look at some more interesting ones. 0 to the 0, 1 to the 0, 1 to infinity is 1, 0 to infinity, infinity minus infinity. These are not numbers. Do not confuse them with numbers. These are just something that the limit is going to. 0 over 0, infinity over infinity, 0 to the 0. And we don't know what's, it's not obvious what's going to happen. If something goes to 0 over 1, we know that's going to 0. If something's going to 1 over 0, that's going to infinity. But these are indeterminate. And it's very important before you try to use L'Hopital's rule that you establish that it's an indeterminate form. If you use L'Hopital's rule on something that's not an indeterminate form, you're not going to get the right answer. You're going to get the wrong answer. I can't emphasize this enough because it's a standard Calc 1 mistake. I'll repeat myself here. Look at the limit as x approaches 0. I mean, it's transparent what this is, but this is going to 1, right? X is going to 0, you're 5 over 5. But if you apply L'Hopital's rule, you get, this is the limit as x goes to 0 of 1 over 2, 1/2, which is, wrong. So don't do it. Okay. So now, I think now we're just going to go over a bunch of examples so you see how it applies to all these different cases. I think I may have done this one already, but it's worth repeating. All right. It's a Catholic class doing the algebra problem. Let me just go through this one. We'll take a break and then we'll do some new ones. Here we have the limit as x approaches 0, but from the positive side. That's because we have in this expression log of x, which is not defined for less than 0. So the limit has to come in from the right. And that's fine. There's no problem as long as there's a indeterminate form. Well, this doesn't look like it's an indeterminate form unless you rewrite it as ln of x over 1 over x. As x goes to 0, ln of x goes to negative infinity. And 1 over 0 goes to infinity. So it's an indeterminate form. So we can apply L'Hopital's rule. So we have the derivative of the ln of x, well, the derivative of 1 over x. Derivative of the ln of x is 1 over x. derivative of 1 over x. That's x to the minus 1 or minus 1 over x squared. I'm going to switch the fraction here. Just multiply by negative x squared, negative x squared. This becomes 1. This becomes negative x. So as x goes to 0, this goes to 0. Might be worth thinking about, well, we could graph this and we could kind of see it, the graph honing into 0. But what this says is that log of x is going to 0 slower. I'm sorry, it's going to negative infinity slower than 1 over x. So much slower that you end up at 0. All right. We will pause and we will do some more interesting and exotic examples. Fun. Oh, it was fun.
Like really far from here. And so my family, me and my brother, and we took the trip like late at night. And we just
So we're not quite back yet, but I just wanted you to see 4 equations and 4 unknowns, look for system of equation solver. Put in equation 1, 2, 3, 4, submit. So you don't have to do all that work on homework. I would not make this a homework assignment. I mean, an exam assignment, unless, if I can get a 10-hour slot, maybe. I'm coming for a 10-hour, no.
yes.
In grad school, I had a wonderful teacher over at San Francisco State who was very trusting, and he gave us a take-home exam for our final. Spent 20 hours on it. There's just 10 problems from the class. Okay. Before I go on, I want to mention something. A student last class asked a really good question. I had I'll just make something up. Okay, so this is goes to 0 over 0. He said, well, why aren't you using the quotient rule? This is a good kind of mistaken understanding question, but it's a good question. Derivative of f times g minus derivative of g times f over g squared. This is not L'Hopital's rule. L'Hopital's rule is derivative of the function over the derivative. So keep that in mind. Do not use the quotient rule here, except as it might apply to one of these functions. But as far as what's going to 0 over 0, the numerator function, we find its derivative. Denominator function, we find its derivative. So, okay.
How do you know it's going to go to 0 and 0?
Well, let me first show how I know here, right? e to the 0 is 1. 1 minus 1 is 0. 1 minus, well, x goes to 0, that's 1. Oh, I'm sorry. This is an error. Here we go. Right. Yeah, my mistake. Yeah, thanks for catching that. What I had here before, that actually goes to 0 over 1, which just goes to 0. But you can just plug in the value that in the problems I'm going to give you, that's going to be the case. It'll just be obvious. Unless it isn't, in which case you should go, wait a minute, I can't use L'Hopital's rule. And then presumably you'll either find it's either going to some obvious constant, to 0 or to infinity. All right. Promised you something more exotic. So here we have the limit as x approaches 1 from the right of 1 over ln of x minus 1 over x minus 1. So ln of 1 is 0, so this is going to infinity. And 1 minus 1 is 0. 1 over 0 is going to infinity. So I have infinity minus infinity. We don't know what's going to happen on the way there. But because it's an indeterminate form, we know we can use L'Hopital's rule. Now, this is not a fraction. It's not a single, function over function. But we haven't lost our algebra skills. We can put it over a common denominator. So we're going to get x minus 1 minus log of x over x times log of x. And you can check this now. So this is 1 minus log of 1, which is 0. And this is 1 times log of 1, which is 0. So it's also, you can think of it as now it's going to 0 over 0. So, right, we can apply L'Hopital's rule. Derivative of x is 1, derivative of minus 1 is 0, and derivative of log of x is 1 over x. That's in the numerator. In the denominator, we have a product, so we have to use the product rule. It's x times the derivative of the log of x, which is 1 over x, plus log of x times the derivative of x, which is 1. So we end up with 1 minus 1 over x, or 1 plus the log of x. Well, let's check. As this gets close to 1, the log goes to 0. So we have 1 plus 0. So this is going to 1. And 1 over 1 minus x, well, that's going to 0. So the limit is 0. I would like to I'd like to just show how you can use something like Desmos or your calculator and verify this, see what's actually going on. So it's 1 over the log of x minus over x minus 1. to hate that. You make a mistake, but love it when I catch it. It kind of looks like I made a mistake here. I'll have to go take a look. Looks like as x gets close to 1, this gets close to 1, or 1/2. Now it's undefined there, but you can see close to it. It's 503 or 509. All right, well, good. I caught my error. All right, let's try again. Find my mistake. So x log of x. Oh, somebody caught this. All right. Well, that's different. Okay, so again, we're going to use the product rule. X minus 1 times derivative of log of x is 1 over x plus log of x. That's fine. All right, what happens here? As x goes to 1, this goes to 0. This goes to 0. This goes to 0. Oh. Oh, this could happen. We started with an indefinite form, and we have another indefinite form. We're still not sure what this is going to, but we can repeat. So we can find the derivative of the numerator, or of the denominator. So the derivative of 1 is 0. 1 over x is minus 1 over x squared. So we get rid of the minus, so we have plus 1 over x squared. Right down here, let's write this as 1 minus 1 over x plus log of x. Derivative of 1 is 0. Minus 1 over x, we just saw that. 1 over x squared plus derivative of the log of x 1 over x. Finally now, we can we? I did it differently in my notes, but I don't know why it was kind of differently. Check here. 1 over x squared is 1 minus 1 over x. So squared plus 1 over x. Oh. This is not sure that this is wrong yet. Let me multiply through by x squared. Aha. So that works. As x goes to 1, this goes to 1 over 1 plus 1. Or half, which is what we saw in the diagram. Okay. I'm doing wrong. Oh, they're both 1. There's no negative. Okay. This is just 1 over 1 plus 1. All right, so that's, you know, a little more exotic, a little more work. Okay, let's look at something that comes out a little differently. This is the indeterminate form, infinity to the zero. You know, the base is growing and the exponent is decreasing, and we don't know what's going to happen. So here we have the limit as x approaches 0 over x to x. This is going to infinity, this is going to 0. So this is, you know, this is this indeterminate form. So we will be able to use L'Hopital's rule. We don't have a fraction here. We could write this as 1 over x, x to the x. But that's still going to have a problem. Instead, we're gonna use a trick that we used before when we were finding derivatives of things with x in the exponent and the base. We're going to define this limit as y, and we're going to find the log of y. We're doing this to kind of get rid of this exponent here. Not get rid of it, but move it somewhere useful. But we have to recall that we're not solving now, we're not using L'Hopital's rule to find y, we're using it to find the log of y. We'll patch that up at the end. So this is the limit as x approaches 0 of x times the log of x. We can do that using the laws of logs. And I guess we want to write this as the log of x over 1 over x. Log of x, as x goes to 0, is going to negative infinity. This is going to positive infinity. So again, we can apply L'Hopital's rule. Log of x goes to 1 over x. 1 over x goes to negative 1 over x squared. I'm going to multiply through by minus x squared. And I'm going to get minus x. So what happens is x goes to 0, minus x goes to 0. That's the limit of the log of y. So y is equal to, the log of y is 0, it's y. Help if I wrote it. Wrote the inverse, right? So that's e to the 0 equals y. Oh, well, that answers the question. Doesn't it? It's equal to 1. Take a look at that. And we're looking at, this goes to 0. This goes to 0. Our limit goes to 1. from the right direction. It's undefined there, of course. All right, any questions so far?
Is it defined on like those little dots?
Yeah. So what do we got here? Let me put this away. So if we have a negative number here, right? Let's say we have -2 to the negative 1 over 2 to the -2. Well, that's 2 squared or 4. So, you know, for some discrete values, this function is defined less than 0. Right?
Is there like a way to find all of those, or you pretty much just have to plot it quick?
Let me say yes, and the dumb answer to how is take a class known as complex analysis, because this is of interest. If you look at this function in the complex plane, right now, wait a minute, we got x, we got y, and now we have 4 dimensions. We've got x real, x imaginary, y real, y imaginary. So it's 4 dimensions. So it becomes tricky to view it. We can take slices of it. And what we would find is it's a smooth curve. It only intersects the real plane at those dots. And it's particularly lovely looking kind of stuff. You know, you get spirals and weird things. And, I think at one point we looked at the, what's it called, the fractal. Well, we looked at a pretty fractal that, you know, we could zoom in on and color it so it looks really pretty. Yeah, you get a lot of that with complex numbers and complex analysis.
So those are like planes where it exists on like X or Y, like imaginary?
I'm sorry, say again?
So those are like planes where it exists on like X or Y imaginary? Like we're, I'm not pointing anything, I'm just like.
What I showed you was just the real plane,
Yeah.
right? If you extend the domain to be complex numbers, then you have to, you know, show the whole complex plane times 2, because there's an X and a Y.
But those are actual lines you're just looking at in different directions.
Well, they're points that are in the real plane. But what do they look like outside of the plane? I don't know.
Yeah.
They're probably some kind of line or surface, probably a surface.
Like you're looking at like a line from like this direction.
Something, yeah, it could be something like that. I don't know. Honestly, I don't know. I haven't looked at that. But you get the same thing when you apply complex numbers to your tree functions. Right? You may not have thought of that, but you can have a cosine of I and you know, what have you. All right. Another strategy using multi-tile rule. For an exponential, find the log, and then when you're done, you've found the limit of the log of something. You can work backwards. Okay. Okay. Here's an example of 1 to infinity. And you might think, 1 to any power is 1, right? Well, this is a limit. The base is going to 1. The exponent is going to infinity. We don't really know where it's going to turn out. All right, so here we have an example. Y is the limit as x approaches 1 of x to the 1 over 1 minus x. Kind of unclear. X is going to 1 minus x is going to 0, 1 over x is going to infinity. So it's going to this indeterminate form. And we're going to use the same strategy we did in the previous example. We're going to find the log of y. And then this x equals 1 of log of x minus 1 minus x, which is log of x times 1 over 1 minus x, or log of x over 1 minus x. Well, once again, we can check. The log of 1 goes to 0, and 1 minus 1 goes to 0. So we apply L'Hopital's rule. 1 over x minus 1. We want the limit as x goes to 1. So this is going to 1 over 1 over minus 1 is minus 1. So the log of y is minus 1. And so y is equal to, okay, I need to write this. So if I have log to the base b of x equals y. Y is an exponent. That's what a log is an exponent. So to rewrite it in exponential form, the base to y equals x. So here the base is e. So I'm using different letters, but here we have y is equal to the exponent, negative 1 to the base e, or 1 over e, which is 1 over 2.718. I guess that's about, it's going to be about 0.3 something. And again, I want to go back and graph this, because graphs never lie. Well, let's see how it works. So, let's take a look. X raised to the 1 over 1 minus x. And we're finding the limit as we get to 1, which is over here, which is undefined. I get it right on there. There we go. So at 1 it's undefined, but nearby 0.364, 0.373, somewhere in between there, it's going to 1 over e. I hope this reinforces this idea of a limit where it doesn't matter whether the function is defined at the limit, it can still have a number that it gets closer and closer to. And guess Michael's interested in this. What's going on here? I think this looks solid because you've just got discrete points close together. Down here you can see they're a little more separate.
Those points on the bottom are those like, do they not exist at the top? Like the parts that are missing in the top, are those on the bottom?
It looks that, I mean, here, got -6 and it looks like something's missing here. It looks that way. Senior project in math.
No.
Not today? Okay. All right. Oh, okay. Got one of everything here. One of the things I find really kind of neat about this subject is you just don't always know where these are going. It's kind of the unexpected. This is going to 0 to the 0. Again, completely undefined value, but again, we're just saying the base is getting close to 0 as the exponent is getting close to 0 in this function. There are other ways that could happen, but we want to know what the limit for this function is. So again, we use this strategy of finding the log first. Log of y is the limit. X approaching 0, log of x to the x, which is x times log of x, which is log of x over 1 over x. We've seen that before. Derivative of the top and the bottom are what? 1 over x over -1 over x squared, which is -x. So as x goes to 0, we get close to 0. And here again, since the log of y is 0, y is equal to e to the 0 or 1. Take a look at that. I mean, you know, these are not dangerous toys like in chemistry or physics. You can try this yourself. Oh, there it goes. As we come in from the right, boom. I think that function x to the x, you know, beyond 1, it's going to go zoom. It's going to disappear. But here it is. It dips down and has some kind of minimum. I don't know if we found the minimum. We can find the minimum, right? Find the derivative, see where it's 0. And it finds its way up, approaching 1 as the limit, x to the x. Now, we've seen one of these before. This is the last example for today. The pearl of wisdom, we've already seen it. The pearl of wisdom is sometimes you have to apply L'Hopital's rule more than once. So we're going to look at the limit as x approaches 0 of tangent of x minus x over x cubed. Well, let's see. Tangent at 0 is 0, minus 0, 0, so that's 0. It's going to 0. And x cubed is going to 0. So it's an indeterminate form, so we can apply L'Hopital's rules. It's kind of interesting, right? What's, you know, tangent of x minus x, x cubed. You know, if this is going much slower than this, it'll be 0. If it's going much faster, go to infinity, and maybe there's some intermediate value. So let's, again, find the derivatives. Derivative of the tangent of x is I can't hear you. All right. Square x minus 1 over 3x squared. Okay, what's the secant of 0? Well, the secant is 1 over the cosine, and the cosine goes to 1. So this is 1 minus 1, that's 0 over 0. So we're going to have to apply L'Hopital's rule again. Derivative of the secant squared. Well, now we're going to use the chain rule. 2 secant of x times the derivative of the secant. I wouldn't expect everyone to know this without looking it up. 1 secant times the tangent. Okay, this is still going to 0. Tangent is going to 0. Secant is going to 1. We're still going to the same indefinite, the same form. So what do we have? We have 2 secant squared x tangent x over 6x. Well, at least we know we're not going to have to go any further. We just have to find the derivative here. So this is 2, and I'm going to have to use the product rule and the chain rule. So tangent of x times derivative of the secant of x, 2 secant of x times derivative of the secant of x, which is secant of x times tangent of x, plus secant squared x times the derivative of the tangent, which is the tangent times the secant of x. Okay, over 6. Oh boy. Tangent of x is 0. Tangent of x is 0. This has to go to 0. I think. No! We made a mistake.
Why didn't you use the chain rule the first time around when we had tan x minus x?
Where would I use the chain rule? Tangent of x is secant squared minus 1, 3.
Yeah, and then so when we took the derivative of secant squared x minus 1, we used the chain rule, right?
Yeah, so 2 secant of x times, I'm using the power rule and the chain rule. 2 secant of x times the derivative of the secant of x, which is secant times the tangent. But there's a mistake here, so, oh. I don't know what the mistake with this is, but my notes tell me I missed an opportunity here. let's try and simplify this. My notes tell me I want to rewrite this, take out constants, and this is secant squared times tangent over x. I want to find that limit. Well, this is going to 1, so I don't even need to look at that. I just need to find 1/3 tangent of x over x. And applying L'Hopital's rule here, 1/3 secant squared of x over 1. This goes to 1, so it should be 1/3. Okay. Take one last graphical look. I hope you picked up that I really approve the idea of checking your homework. Using a tracking device. It might not always help, but in this case, this is a great looking function, isn't it? I mean, you can kind of see the influence of the tangent here, but what's going on over here? But at least as we get to 0, you can see quite plainly it's getting close to 1/3. All right, you'll have some homework to do with finding limits using L'Hopital's rule. You know, with great power comes responsibility. Don't use L'Hopital's rule if it's not in indefinite form. And I'll